All right, guys, here we go. So Unit 7, Day 1. Unit 7, we are looking at exponential functions and logarithmic functions. Specifically today, we're going to look at formulas of an exponential equation. How does the initial number, the starting number, affect the end result of an exponential function, and what situations represent exponential growth and decay? We're doing this zombie attack. Yes, the key is attached, but I would like for you not to necessarily look at the key as we go through as you're on your Chromebook. We're going to study exponential growth and decay. And then, like I said, when we're done, you are more than welcome to work on this homework, which is not due until day 3 down here in the calendar. And you can look on that date. Or you can work on test corrections just in the event that you have to retest by tomorrow. Okay? Yes, my goal is to get all grades completely updated by today so that you will know where you stand with that regard. I'm not even going to joke about this unit. This unit is very, very powerful and a lot of real-world application. And I'm talking about when you're buying cars, when you're buying houses, when you're doing investments in your future. If you know this math, you won't necessarily get ripped off. And I have some stories to share with you in that regard. Not me getting ripped off, but some people who don't know the math of what they've experienced, and we'll look at the math behind that. We'll look at numbers that were correlated. Like I had a friend in the Marine Corps, he got big time ripped off when he bought his first car. And I'll give you that story here in just a bit. But I do want to go ahead and start by looking at this activity of zombie attack, and we're going to study pretty much what is exponential growth. Okay, so let me go ahead and go to this screen here, and let me ask you, we have a lot of functions that we've learned so far. We've learned y equals x, we've learned x squared, we've learned square root of x, we've learned absolute value of x. What other functions have we learned? The cubed root of x. You with me? We've learned x cubed. Well, today we're going to learn the exponential function. Okay? And if I told you which one of these grows the fastest, which one would you say? Which one grows the fastest? X squared. Okay? The reason why is that x squared looks like this, where x is just a line, square root of x grows but slowly, absolute value of x grows but at a steady rate. Like this slope right here is the same all the time. It's just a slope of 1. You with me? And then this cubed root of x looks something like this. It grows but slowly forever. But x squared grows fast. As you go to the right, it grows fast. You with me? Over a short period of time. Can you tell me why it grows fast? What mathematically do you think makes it grow fast? Marcus?
Yeah, because it's being multiplied by like the number itself, so like bigger the number, it like compounds more.
Okay.
The difference between 20 times 20 is a lot more than 19 times 19.
He's exactly right. Multiplication. Mecca, how many times are we multiplying this by? Itself. So x times x. If x was 9, it's 81. If x was 10, it's 100. But it's multiplying by itself. Exponential functions are new. And they look like this, or they look like this, or they look like this. You see what I'm saying? If x is 0 on this graph, okay, so if x is 0, what would 2 of x equal? Or 2 to the power of x? be 1. What if x, and when I say if x was 0, guys, I'm talking about this x is 0. You with me? What if x was 1? What would it be? 2. What would if x was 2, what would it be? 4. Here we go. What if x was 3? 8. If x was 4? 16. What am I doing each jump that I go down? I'm doubling it. And the reason why I'm doubling it is because the base is saying that I'm doubling it. You with me? Okay. So let me ask you this. What would I be doing here? I'd be tripling it each jump. Rather than doubling it, I would be tripling it each jump. You with me? And then I would be multiplying it by a form of 5 each jump. Alright, so now let's go back over here to our zombie worksheet. And let's see what's happening with exponential growth. Okay? Let's go. Casey, can you go ahead and read that for us?
On June 30th, 2035, a sleeper cell of zombies executed an evil plan 10 years in the making. Their objective to turn the entire human race into evil zombies. Each zombie can turn 3 humans per day, but they are not sure how long it will take to completely turn every human on the planet.
Okay.
Complete the table below to show how many total zombies there will be every day for the first 10 days of the attack. The original sleeper cell had only 5 members, but keep in mind that the newly turned zombies also have the power and the will to turn to other humans.
We good? Alright, so their objective is to turn the entire human race into zombies, and each zombie can turn 3 humans per day. And then the next day, from those that were turned, each of those can turn 3 more humans, and so on and so forth. Okay? That's the premise here. Alright, so let's go to the number of zombies. So on day 0, like the first day, the number of zombies turned each day, the number of zombies there are 5. Okay? So if there's 5, how many zombies are turned on day 1? 15. Because what did we do? We multiplied by 3. There was 5, and we multiplied by 3 to get 15. Okay? So now that there was 5 and 3 from the day before, on day 2, we're going to multiply that by 3. It's like multiplying 15 by 3. You see what I'm doing? Which will give us 45. Okay? Sophia, what would I do on this third day? Multiply it by an extra 3. So the way she said that was perfect. So what happened the step before, we're going to multiply by an extra 3 so that we get 45 times 3. And what's 45 times 3 going to give us? 135. Okay? So just real quick, I want you to start doing the math and seeing how many were these other tables produced. Okay? So if I were to go to my calculator, I already know it's 135 for that one that I was just looking at. And we just multiply by 3, we get 405. Multiply that by 3, we get that. Multiply that by 3, and so on and so forth. We're multiplying the previous answer, which you can press Control Answer on yours. So it's Control and then this negative sign, and then multiply by 3. And it's just growing each jump of the way. Okay? So we would have 5, 3, 3, 3, and then we get 405. And I think you get the gist of it now. 12, 15, 3, 6, 4, 5, 10935, 32805 times 3 more would have given us 98415, and then times 3 would have given us 295, 245. Do y'all know what the equation is going to be? So that I don't have, like if I asked you on day 30, you didn't do this 30 times. You just have one equation that it did it for you like that. What do you think that equation would be?
5 times 3 to the power of x.
Nice. 5 times 3 to the power of x. So, what does this 5, he's exactly right, but what does this 5 represent? The starting value. So look, y equals mx plus b. This is the starting value. This is where you start. And the change that happens each jump of the way, they have a correlation right there. So let's say that we had an equation back in Algebra 1 that looked like y equals 3x plus 5. That means 1, 2, 3, 4, 5. This is what my y-intercept is. That is where I start. And each jump to the right, we are going to have a slope of 3. So it's going to go rise up 3 over 1. That is the slope of 3. So the next one would be 8. Then 11. You see what I'm saying? Then 14, 17, 20. But here it's different of how fast it grows. You with me? We still start at 5, but then the next one will be what? 15. And then the next one, 45. Then 135, because we're multiplying what the previous one was by 3. We're not just adding 3 each time. You with me? We're multiplying our previous thing by 3. Okay? Let's say that I made a deal with you guys. And I wanted to see if you knew your math. How many of you would take this from me just for coming to class? If I give you $5,000, do you think you'd be absent a day? No. Would you? Let's say that I gave you this for 30 days straight. How many of you would like this, or I gave you that much money per day, or that much money on the first day, and I doubled each and every day? For 30 days. So here we go. Day 1, 2, 3, 4, so on and so forth. How much money do you have on day 1? 5,000. How much money do you have on day 2? 10,000. And you're already nice, smiling, right? How much money do you have on day 4? 15, and then 20. So if I put this into my calculator, I could know how much that I would have after 30 days. It's a lot of money, right? How many of you would actually want this deal instead? Raise your hand. Everyone should be raising their hand, right? Because although it looks like a very little bit of money, the power of exponential functions is this. They start growing very, very, very slowly, and before you know it, way down the line, bam, it just shoots up. Go with me? So the equation here is just going to be 5,000 times x. And if I said x was for 30 days, then you would just multiply 30 by 5,000, and you get something like 150,000, which is still pretty good money. You with me? Well, let's go over here. What's the equation that I would use on this model of exponential growth? y equals what? 0.01, which is what I start with, times 2. Why is it 2? Because I'm doubling each jump. From the jump before, I doubled. From that, I doubled. And it's just doubling as we go through. All the way to x. Go ahead and put this into your calculator. And I want to go ahead and put 0.01 times 2 raised to the power of 30. It's a big number. It gives you this to where if I press enter, it'll register it as what? $10,737,418 from pennies, from a penny that you put at the very, very, very beginning. Why? Because of the power of exponential growth. Let's try to do this. So real quick, what I'm going to do, and I'm going to show you this because I want you to learn, is 0.01 is our initial value. We're going to multiply by 2 raised to the x power, and I'm going to control vars. I'm going to store this as f of x. So if I wanted to know how much money do I have on the first day, I could press f of 1, or after the first day, after 1 day has passed. Okay? So what I should have done on the other one was actually 29. Okay? I should have done this to the power of 29 to show how much would I have on that 30th day. Because this means 29 days have passed. But still, that's pretty good. That's 5,368,709 and 12 cents. Okay? So, but with this function that's saved, I could now put, how about after 5 days? How much money do I have? 32 cents. You see where I'm going with this? How about after 6 days? How much money do I have? 64 cents. It's not still very, very little. How about after 15 days, halfway through the month? I'm still way under 5,000 per day. And then I do f of 20. Then all of a sudden it starts growing pretty fast. And then f of 21, it's doubling. F of 22, f of 23, and it starts shooting up big time now. And then you're just doubling it each time. Yeah.
So if you're doubling the amount you're giving us, so if you give us 2 cents on the first day, and the second day you give us 4 cents, on the second day wouldn't we have 6 cents in total?
So here's what I'm saying. I don't give you. What's happening is, what do you have in the bank? How much is accumulating? So all I did you hear what he said? That's a big question. I didn't give you more money each day. I only allowed the math to double what was given. Do you understand? So it's almost like you invested 1 penny, and then it doubled each time. And then at the very, very end, I would give you everything all in one check, if you will. You with me? Whereas the other one, I said, oh, I'll give you 5,000 each day. Just keep track of how many days, and when you get to 30, I'll give you everything at one time. But the growth is happening slowly, slowly on the exponential, and all of a sudden it shoots up. You with me? All right, check this out. Any questions right now before we keep going? All right, so when I bought my first car, 18 years old, bought my first car before going to the military. It was an $18,000 car. And I used my dad to help me buy it, and he co-signed for me because I didn't have credit. I didn't have credit cards, so I didn't build credit. And credit is basically trust from the bank, that they know that you're going to pay off that money. The bank pays the car off for me. It gives the dealership that 18 grand, and now I'm indebted to the bank. And I have to pay the bank off. The bank said, you will pay me off in 5 years. But we need to make money off of you. So we're going to charge you interest. The interest rate that they were wanting to give me was close to 12%. Because I had no credit. But then my dad co-signed for me, and I borrowed his credit. So co-signed for me, and and I got it down to 3%. You with me? 3%. So how much percent am I expected to pay for the car? How much percent by default are you expected to pay for a car? 100%. And now the bank wants its cut. The bank says, we're giving you this 18 grand so that you can buy the car, but we want a percentage of that cut. So it's going to be 100 plus 3 to give you 103%, which is 1.03. This would be my base. This would be the start. And this would be the number of years. You with me? So if I looked at this, let's go ahead and plug this in. I have 18,000 is multiplied by 1.03 raised to the power of 5. I ended up paying $20,866 for this $18,000 car. Whoops, I don't know why I did that. Should have subtracted, I don't know what it did. Oh yeah, so I owed the bank made off of me. It profited $2,866.93. You with me? So a friend of mine, he does well for himself now, but unfortunately he still doesn't know how to work with money, doesn't know the math behind it, bought a car when we were in the Marine Corps, around the same time that I bought my car. He didn't have the help of his parents, he wanted to do it by himself. So he went and bought a car with a credit card. Not a bank, but with a credit card. Guess what interest rate he got? He got 20% interest rate. His was 20 grand. So the 20% that's added to that 100% became 1.20, and he paid it off in 5 years. So 20,000 multiplied by 1.20 raised to the power of 5, he paid $49,766 for a car that was only worth 20 grand. Luckily, he was saved by the Marine Corps and whatnot, as far as the fraud that they were trying to commit on this brand new teenager, but that doesn't work with everyone. If you get stuck and you make a deal like this because you don't know the math, can they take advantage of you? They, per se? Can people profit off of you from not knowing this powerful math? Yes. House, investments, Wall Street, stocks, whatever it is that you're investing in, and even cars. Okay? Any questions? All right, so let's go ahead and move on.